Hey guys, I went ahead and answered these DESMOS problems, so I'm just going to run them down real quick. Finding the slope between two lines, between 2 points. If it's just given to you as ordered pairs, normally you just want to use slope formula. It's true that you could graph the points and count the rise and count the run, but however, when you just have two coordinate pairs, you can just subtract using slope formula y2 minus y1 over x2 minus x1. That'll give you the rise over the run. And so if you call the first point x1, y1, and the second point x2 and y2, what you'll end up with is 7 minus 2, which is what I have here, and 5 minus negative 8, which is what I have here. 7 minus 2 is 5. You can see my answer there. 5 minus negative 8 is really 5 plus 8, so 13. So 5/13 is the slope here. The next slide we have same skill, so you would get 10 minus negative 4. Remember, subtract the y's on top. 10 minus negative 4. Then on bottom the x's, 17 minus 15. 10 minus negative 4 is 14, as you see here. 17 minus 15 is 2. 14 over 2, though, that reduces to 7, so the slope of that line is 7. It's positive, so don't forget certain things about slope, like if it's positive, the line will be rising. If it's negative, the line will be falling, which kind of segues right into this problem. This line has a negative slope, so it's definitely falling. Again, negative slope, falling. But how do you graph a line, right? If it's in this form, y equals mx plus b, which I have here. If it's in the form y equals mx plus b, m is the slope, so negative 2/3 is the slope. B is the y-intercept, that's 5, so just restating here, the line's falling. Again, slope here is negative 2/3. Y-intercept b is 5. Remember, b for begin, m for move. Once you know what the slope and y-intercept are, b for begin by going 5 up, put a point there, so that's this point right here. Then your slope is negative 2/3, so it's down to right 3, which I've kind of highlighted here, but down to right 3, and you can continue going down to right 3 if you want to keep putting points on this line. So there's that. Again, you begin and move. Begin by going up 5 and then move with the slope down to right 3. Remember, if the slope's negative, it's down and right. If it's positive, you go up and right. It is true that there's more than one way to do this, but that's kind of how I'll instruct it. Next one, same thing. So your slope and your y-intercept. Your y-intercept begin at negative 8, that's b, and then your m, your slope, 4. So make it a fraction, that way you can rise and run. If it's a whole number like 4, put it over 1, and then graph. So you graph begin by going to negative 8. Different than the last problem, since it's negative, you'll go down. So you begin by going down 8, put a point there it is. Then your slope is 4 over 1. Rise 4, run 1. And since it's positive, it's up and right. So up 4, right 1, and I can keep going up 4 and right 1. Here I'm showing 1, 2, 3, 4 up, right 1, and so on. So again, that's begin at negative 8 by going down 8, and then move with the slope. It's 4, so up 4, right 1, up 4, right 1. Begin and move. Okay, don't forget that. Begin and move.
Mommy, those wiffle balls are super squishy.
Really? So that last part, I
say.
wasn't sure if I was going to delete it, but I just left it in there because my son said to leave it. So anyhow, so now you know the wiffle balls are super squishy. Moving along here, so in this one I'm supposed to find the slope, the y-intercept, the equation of the line. All I'm given is this table. The white the inputs with the white background are the ones that I filled in. And I fill them in by, first of all, guys, if you check the x coordinates, they are consecutive. It goes negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. What I'm saying is it doesn't skip numbers. It doesn't go like 1, 3, 6, 20. It doesn't skip. They're in order, aka they are consecutive integers, in which case I can simply look at these outputs and see how are they changing. In this case, they are changing by subtracting 3 with each consecutive output. 15 minus 3 is 12, minus 3 is 9, minus 3 is 6, minus 3 is 3, and so on. So if I continue subtracting 3, like 0 minus 3 is negative 3, negative 3 minus 3 is negative 6. So I keep subtracting 3 here to basically to get the rate of change, aka the slope, aka m. Remember, your slope has quite a few different ways to identify it, or just kind of to define it. Like, you can define slope as rise over run, but you use the symbol or the letter M to identify it. And anyhow, it's also called your rate of change because it does tell you how quickly or slowly something is increasing or decreasing. So anyhow, this is a -3, guys. Slope is -3 because these outputs are decreasing by 3. And the y-intercept, you can find that where x equals 0, and where x equals 0, we see y is 3, so 3 is your y-intercept. And so again, m is -3, b is 3, and then if you fill those into y equals mx plus b, well, I'll just do that real quick. You'll get -3x plus 3. So there's that. And let's go to the next one. This one is similar. So finding the slope on this one, the thing that's different about this one is these x coordinates are no longer consecutive. It goes from -2 to 0, then from 0 to 2. So like there's no 1 here. So since there's no 1 here, or even here, it goes 0. There's no 1, 2, 3. There's no 3, 4. Oh, actually, these I filled in consecutively after I figured out what the slope was. So just imagine inserting a 1 right here. If we were to insert a 1 here, check this out. So it goes from 3 to 10, and then from 10 to 17. So it is adding 7 every time. It's definitely, I'm just gonna kind of indicate that it's adding 7 to each input to get the next input. The problem is they're not consecutive. So if there was a 1 here, it would really only be going up by, instead of 7, 3.5. So half of 7 basically is what your slope is, 3.5. So it goes up by 3.5. It would go 3 plus 3.5 would give me 6.5. And then if I were to add 3.5 again, 6.5 plus another 3.5, I get 10. So, and I'd go to 0, and then if there was this would have been, my bad, this would have been a -1, not a 1. And then here, imagine if there was a 1 there. Well, when it goes from 0 to 2, it goes up by 7, which means it only would have went up 3.5 if there was, consecutive integers. So I'm just trying to let you know that the slope is 3.5, and I'm going to just input a 13.5 here, because if there was a 1 in there, then a 13.5 would be the output. So again, since these inputs are increasing by 2, you got to recognize that and recognize that the slope isn't 7, it's actually 3.5. So here, when I make them consecutive, I go 4, 5, 6. Now that they're consecutive, I'm just going to add 3.5. 27.5, 30. So if your inputs aren't consecutive, finding the slope can be a little tricky. Anyhow, it's 3.5. Remember, your y-intercept is where x equals 0, and where x equals 0, you can see y is 10, so that's my y-intercept. And then y equals mx plus b. So in this one, y equals 3.5x plus 10. So there's that one. Again, be careful with, if the inputs are not consecutive, you'll have to kind of think about that and decide what your slope really is. This one's really just plugging in numbers. If you plug into f of x, right, if you plug in a number, you're going to go -4 times that number plus 9. Same thing with g of x. If you plug something into g of x, you're going to take that number squared and subtract 12. So you would have, for f of -3, you guys would plug a -3 in for x, and you'd get -4 times -3 plus 9, -4 times -3 plus 9. Over here I didn't write it, but you would put f of -3, right? We'd say f of -3 equals -4 times -3 plus 9. I only wrote this because really this is the work. This is how you figure out what the output is, right? When the input's -3, you figure out the output. really this is what you do. So -4 times -3 is +12, and 12 plus 9 is 21. So f of -3 here is 21. And then g of 5, well, g of 5 would be g of 5 would equal 5 squared minus 12. So for the second one, if you did 5 squared minus 12, 5 squared is 5 times 5, 25. 25 minus 12 is 13. So g of 5 equals 13. In this one, from the graph, find the following. Find f of 3. Well, if you're finding f of 3, all you got to do is go to 3 on the x-axis and see where the graph lands. If you go to 3 on the x-axis, it looks like the graph lands right here at 5. So f of 3 is 5. Find f of -4. So remember, if -4 is the input, what's the output? AKA, if x is -4, what's the output? Well, here's x is -4, guys, and you can see where x is -4, y is 0. So f of -4 is 0. It says find one x value for which f of x equals -4. So this is basically like saying y equals -4. So y equals -4. Again, down 4 right here. So here's one point where y equals -4, and here's another point where y equals -4. So could answer either one. It says give one point where f of x, aka y, equals -4, which that would be here and here. So you could say 0 or -6, which is what I have here. And then find one x value for which f of x equals 2. So again, it's find an x value where y equals 2. So that's up to y equals 2 here. An x value where y equals 2 is right there, which is at, you can see it's at -3. And another x value where y equals 2 is here, but it's, if you go down, it's not exactly 2, so that's why I put about 2.2. It's between 2 and 3, so I just estimated 2.2. Whatever you estimate should be fine. Hopefully you would agree that it is not 2, right? Again, here is where the graph crosses at y equals 2, but x, if you go straight down, whoops, if you go straight down, you get to, the x-axis, and that is definitely not exactly 2 or 3. So I said 2.2. Anything in between 2 and 3 would be kind of reasonable. It definitely, to me, looks like less than 2.5, though. And then the other one's obvious, where y equals 2 at negative, where x is -3. So there's all of those. This one was probably one of the easiest ones, or if not the easiest one on the practice here. So label the parts that are increasing with red. So anywhere the graph is moving upward or rising, I labeled it or highlighted it with red. So 1, 2, 3 different spots. Highlight the parts that are decreasing with blue. So the graph is going down, right? It's decreasing here, and then it's decreasing here. So that's, again, highlight in blue the decreasing spots. Then highlight the parts that are constant in green. So right here where it's flat, right, and right here where it's flat, those are your constant parts. So pretty straightforward on that one. And then this one. First of all, I got to give it up to Mr. Hinckley, because I love me some Lord of the Rings. So the fact that he wrote a problem like this, really, it's just funny to me. It's awesome. So Frodo first of all, let's read this. Draw a sketch of a graph that depicts the story below. It should represent Frodo's distance from home over time. Label each axis. So Frodo's distance from home over time. If you think back to the beginning of this unit, time normally went down here on the horizontal axis, and then this is hard to read, I know, but I put D-I-S-T-A-N-C-E. I'm saying distance here, guys. Frodo's distance from home over time. So again, this is Frodo's distance from home over time. I already drew the graph. It says, I'll read it as I kind of show you how the graph says. It says, remember, this is how far away he is from his house. So as the graph is increasing, he's getting further away from his house. If it stays constant, he's not getting further or closer. If it's increasing, he's getting further away. Right here where it's flat, he's not moving. And then if it goes down, it means he's getting closer to home, because his distance from home is decreasing. So Frodo Baggins decides to take a walk through the Shire. He starts walking at a steady rate. So here's that. He starts walking at a steady rate away from Bag End, his home. He stops for a few minutes. That's his flat part. He stops for a few minutes as an eagle brings a message from his pal Gandalf. So he reads that. After responding to the message, he continues at the same steady rate. So he's continuing here at the same steady rate. And then see where I'm at. He suddenly sees. I love this part. He suddenly sees Lobelia Sackville Baggins. So he doesn't like her. He doesn't want to talk to her at all. So he jumps behind a tree and reaches into his pocket for the One Ring. So when he sees Lobelia Sackville Baggins, he hides behind a tree. So that's that's this part where he's hiding and he's not moving. That's this flat part. And then so he's reaching into his pocket looking for his One Ring. It's not there, so going berserk, he runs all the way home. That's this part. He's running all the way home till he gets home, right? Once he gets home, he is 0 distance or 0 feet from his home. That's why the graph goes all the way down to 0, because when he runs home, he's 0 feet or 0 miles, 0 distance from home, basically. So anyhow, again, so steady rate, constant, steady rate, constant, and then all the way back home.